All right, so we're going to look at polynomial and rational inequalities. So we're familiar with both polynomial and rational. We're just going to add the inequality part in there. And so here are some examples of what they're going to look like. So this really shouldn't be too bad once you kind of get the process down. So solve each polynomial inequality, graph the solution set on a real number line, and express the solution in interval notation. Okay, so here's the hint. This is basically how these are going to work. You want to find the x-intercepts and then test values between the x-intercepts and beyond them. Okay, so any x-intercepts you find, test the point that's between them and then beyond them. And I'll show you an example in just a second. If the tested value within a subinterval, and so I'm referring to the distance between or beyond the x-intercepts satisfies the inequality, then all the values within that subinterval will satisfy the inequality. So let's look at this first one. They're not all going to have pictures, but at least on the first one, you kind of want to have a graph so you can kind of visualize this. So we're trying to figure out right here, we have x squared minus 7x plus 10, and we want that to be greater than 0. Basically, you want the results to be greater than 0. So when you look at this xy axis, the y is basically what you're going to get in return. It's basically what you plug in for x, and then what comes back is kind of like your y value. So you want your, basically we want the y values to be greater than 0. So looking at this graph, you can see where y is greater than 0. This interval right here between negative infinity and then at 2 right here, and then from 5 to positive infinity. So those are going to, that's the actual answer, but I'm going to kind of walk you through this because they're not always going to be so obvious, especially because we won't always have a picture. Okay, so typically what we're going to do, so let's kind of assume we don't know what our answers are here. What we're going to do is we're going to take the polynomial and we're going to factor this. And so this would factor into x minus 5, x minus 2, and so those x-intercepts are going to be at positive 5 and positive 2. So those are your x-intercepts. So I'm going to put them on this number line right here. So 2 would go like right here, and then a 5 would go about right there. Okay, so now what we want to do is you want to test. We're going to test a point. So an easy point to test would be like 0, right? And so what you want to do is you want to plug it back into the, you can plug it into the original equation, or you could plug it into this factored form. A lot of times the factored form will make things a little bit easier. Okay, so if I were to let x equal 0, what would happen is I'd have 0 minus 5 times 0 minus 2, and we want to figure out, is that greater than 0? So I could have plugged it into the x squared minus 7x plus 10, and that's fine too. But as they get more complicated, you'll see that it'll be easier to plug it into this factored form right here. And so what happens is we end up getting negative 5 times negative 2. Well, a negative times negative is positive. 10 is greater than 0. That is true. Okay, so we know that this interval works. Now, what's important is the inequality sign. Now, the inequality sign says it has to be greater than 0. If you plug in 2, it will actually be 0, and so that would be a false statement. So at 2, that's not going to be included, so we'll put an open circle there. But 0 works, and that means all the values in this interval work. So if you were to plug in 1 would work. If you were to plug in any negative numbers, they would work. Okay, so all of this works right here. So that's that interval from negative infinity to 2. And then we have to check the other intervals right here. So now we're going to check, you could plug in 3 or 4 or whatever you want. I guess we'll plug in 3. Okay, so x equals 3. So once again, I'm going to plug it into the factored form 1. So let's see, 3 minus 5 times 3 minus 2, is that greater than 0? So let's see, that'll end up giving us negative 2 times 1, which is negative 2. Negative 2 is not greater than 0. That is false. So we don't want to shade that interval right there between 2 and 5, right? Okay, then our last interval is from 5 on to infinity, so you just have to pick something greater than 5. We'll keep them small, so we'll pick 6. So x equals 6. So let's see, we're going to have 6 minus 5 times 6 minus 2. Is that greater than 0? So we're going to end up getting 1 times 4 greater than 0. 4 is greater than 0. That is true. Now, once again, 5 is, we call those boundary points. You can see it says it right there, because sometimes they'll be included, sometimes they won't. But basically, there's a change in the sign. Y was positive, then negative, then goes from negative back to positive. So this boundary point is not included. Sometimes they will be included, though, so don't assume that they're never included, because if this would have been a greater than or equal to sign, then we actually would be including those points. Okay, so that interval from 5 above is good. So we want to include that as part of my interval notation. So from 5 to infinity. Okay, so that's going to be the reoccurring theme in this section. It takes a little bit of practice, but it's really not that difficult as long as you know the pattern on what to do. But we won't always have that picture. So let's look at number 5. Okay, so on number 5, well, first of all, this is something we haven't seen yet. You want to go ahead and set it equal to 0 if it's not. That just makes the process a lot easier. So x squared minus 1 is less than or equal to 0. So I basically subtracted 1 from both sides. So what we're trying to do here, if you're kind of thinking of a graph, so you're going to plug in x and you want the results to be less than or equal to 0. You basically want y to be less than or equal to 0. That's kind of what we're looking for if you were kind of thinking of this as a graph, okay? So what we need to do here is factor this. So this will factor into x plus 1, x minus 1. That needs to be less than or equal to 0. So those intercepts are going to be at -1 and +1. Now this time they are included because of the less than or equal to. Because if you plug in either one of these, it will be equal to 0. So they will be included. So let's see, -1 and +1. And if you want to, you can go ahead and put closed circles there, because we know we're going to include those points. Okay. And so now we need to test something over here like a -2. We need to test 0 and then test +2. So just like what we did up above. So you find the x-intercepts, test points between any x-intercepts and beyond any that are between your infinities, negative and positive infinity. So we'll start with x equals -2. Once again, I'm going to plug it into the factored form, and I'm going to start doing some of this math in my head. So if I were to substitute this in right here and right here, this would end up giving me -1 times -3 less than or equal to 0. So I get +3 is less than or equal to 0. That's going to be false. So we do not want to shade that part. And then let's see if x equals 0. So if I plug in 0, I'll end up getting 1 times -1 less than or equal to 0. -1 is less than or equal to 0. That is true. So we do want to go ahead and shade that interval right there, which is between the intercepts. And then our last interval is between 1 to infinity. So we'll go ahead and plug in 2. And so when you do that, we're going to get 3 times 1 is less than or equal to 0. So we get 3 is less than or equal to 0, which is false. So we don't want to shade that. So the only interval that is part of our solution set is going to be between -1 and +1. And I use brackets this time because those endpoints are included. So -1 and +1 both satisfy our inequality. Okay. All right. So here's another one. So this one's kind of interesting. So when you factor this is going to factor into x minus 3, x minus 3. Okay. and this is less than 0, right? So you only have one x-intercept, and that's going to be at 3 right here. Okay, so we'll go ahead and put 3 right here. And so I can test between there and negative infinity and positive infinity. So I want to test, 0. If 0 is available, you always want to test 0. 0 is pretty simple. And then here we can test a 4. So if I plug in 0, I'm going to end up getting negative 3 times negative 3 is less than 0. 9 is less than 0. 9 is less than 0. That is false. Okay. If I plug in 4, I'm going to get 1 times 1 is less than 0. 1 is less than 0. That one's false too. Okay. What about my boundary point, my x-intercept? If I plug in 3, would that be true? Let's see, if I were to plug in 3, it would be 0, but 0 is not less than 0, so that'd be false too. So actually, there's no solutions. It's an empty set. So what we would do here, which on your homework, you'll see a little symbol like this, which just means empty set. There are no values that will satisfy this inequality right here. Okay, you won't run into too many of these. Probably only be one of those on the homework. It's kind of a little bit of a trick question, just make sure we're kind of thinking this out. So anyways, if you plug anything in, it does not work. Okay, I think I got a couple left. Okay, so on this one here, let's see, we need to factor this. So I'm going to factor out a negative x, and that'll leave me with x minus 1. Okay, you could have just factored out positive x if you really want to. It's just kind of a force of habit that if the leading coefficient's negative, you kind of want to factor that out with it. Okay, so our x-intercepts for this one, that would be 0. If you let x equal 0, it's going to cause the equation to go to 0. And your other one's going to be at positive 1. Okay, so let's see, we'll put 0 here, we'll put 1 here, and so we're going to have to test something over here like negative 1, then we're going to have to test something right here like 1/2, and then something over here like 2. Alright, so here we go, so let's see, x equals negative 1, so we're going to get negative 1 times, so when I plug in negative 1 here, that would turn into a negative 2 when I subtract that 1 from it, is greater than or equal to 0. So we're asking ourselves, is that true? So the double negative right here, that will turn into a positive 1 times negative 2. So then we end up getting negative 2 is greater than or equal to 0, which is false. So this part does not work. Now let's look at 0. If I plug in 0, it will make it equal 0, which is it'll be greater than or equal to 0. So I know 0 actually is a good answer. So I'm going to go ahead and include that point. And same thing with the 1. If I were to plug in a 1, it would cause the expression to equal 0. So that I know that one works too. Now we got to figure out, does 1/2 work? Does 2 work? And so on. So plugging in 1/2 might be a little tricky, but I think we'll be okay. So let's see, we're going to have negative 1/2 times, and then 1/2 take away 1 would become negative 1/2. So if I have 1/2 minus 1, I'll show my math just to make sure, don't lose anybody here. So what I have to do here is get a common denominator. So I'll have 1/2 minus 2 over 2. Okay, so I changed that minus 1 into a minus 2 over 2. So I end up with negative 1/2 times negative 1/2. Is that greater than or equal to 0? So a negative times a negative is positive. So this actually becomes positive 1/4 is greater than or equal to 0. And that would be true. 1/4 is larger than or equal to 0. So we'll shade between there. Okay. And then now we'll try 2. X equals 2. So let's see, we'll get negative 2 times, and then when I put 2 minus 1, that would become 1. Is that greater than or equal to 0? Negative 2 is greater than or equal to 0. That is false. So we don't want to shade that part. So my solution set is going to be between 0 and 1. Okay, these next few examples, we're going to actually look at some higher ordered polynomials. And by that, I just mean we'll go higher beyond power of 2. Okay, so since this is the first one I'm showing you, once again, I'll kind of include a picture. And so from the picture, you can actually kind of figure out what your answer is. So let's go ahead and do that, and then we'll kind of work it how we did the other ones. Okay, so right here, this expression needs to be less than or equal to 0. Basically, what they're saying is the y values need to be less than or equal to 0. So that's going to be here to negative infinity. It's going to be between here and here, right? Because the y value is negative right here. The y value is negative this whole time. So those are your two solution set, or your two intervals that would be part of your solution set. So from negative infinity to negative 2, between negative 1 and positive 2. So the way this works, just like the other ones, you want to factor it to find your intercepts. So whenever you see 4 terms, you automatically want to think factor by grouping. So on the first set, I'm going to pull out x squared, and that'll leave me with x plus 1. On the second set, I'll pull out a negative 4, and that will leave me with x plus 1 also. And so that's what I want to happen. I want to have the same factor. So now I factor out the x plus 1, and then I have x squared minus 4 is less than or equal to 0. And then we'll factor the difference of 2 squares right here. So we'll have x plus 1, x plus 2, x minus 2 is less than or equal to 0. And then my x-intercepts are negative 1, negative 2, and positive 2. And so that's what we want to put on our number line over here. So negative 2, negative 1, positive 2. And so what we're going to have to do again is test some points here, okay? And so let's see. We'll want to test like negative 3. Over here it looks like we're going to have to test negative 1.5. Over here 0 would probably be good. And then a 3 over here. Okay, so once again I'm going to plug it in here, and I'm going to do a lot of this math in my head since I don't have a lot of room here. So if I plug in negative 3, this would become negative 2 times negative 1 times negative 5. Is that less than or equal to 0? Okay, well, this would become positive 2 times negative 5, and then it become negative 10 is less than or equal to 0, which is true. Negative 10 is less than or equal to 0. So I just was plugging in negative 3 here, here, and here, and I just did the math in my head, saved myself some room. So that does come back true. And then once again, because we have the less than or equal to part, that means we are going to include all the x-intercepts. So if you want to, you can go ahead and put a closed circle on all those to indicate that those points will be included. All right, this next one, I'm going to try to give myself a little bit more space here. So I'm going to plug in negative 1.5. So let's see, that would give us negative 0.5. And then let's see, that would give us positive 0.5. And then that would give us negative 3.5. And so that expression, we want to see if it's less than or equal to 0. Okay, so if you wanted to, you could use a calculator if you want. But basically, you could start thinking about what happens when you multiply a negative times a positive. A negative times a positive will be negative. Then you have another negative that it has to be multiplied by. A negative times a negative would come back positive. Positive numbers are not less than or equal to 0. So that would make this one false. So even if you don't have a calculator, you could just kind of think about that for a minute. Negative times a positive is negative. Then when you multiply by the third number, you have a negative times negative, which would come back as a positive. And positive numbers are not less than or equal to 0. So that one's false. Now 0, that should be a pretty easy one to plug in. So if we plug in 0 here, we're going to get 1 times 2 times negative 2. Is that less than or equal to 0? So when you multiply that all together, it's negative 4. Negative 4 is less than or equal to 0. That one is true. So we'll go ahead and shade between those. And then now we'll try plugging in 3. If I plug in a 3, I'm going to get 4 times 5 times 1. Is that less than or equal to 0? Those are all positive numbers. You're going to get 20 is less than or equal to 0. That is false. So we are not going to include that one. So the way we're going to write our solution set is we're going to go from negative infinity to negative 2, and then union negative 1 to positive 2. And that's our solution set there. Okay, I think I got one more here. Okay, so we want to go ahead and start by setting this equal to 0. So I'm going to subtract 9x squared from both sides. So I'd get x cubed minus 9x squared is greater than or equal to 0. And then what I could factor out is the x squared, and that will leave me behind with x minus 9 is greater than or equal to 0. So my x-intercepts are going to be at 0 and 9. Now notice that your 0 solution has a multiplicity of 2. And so what you've learned about that from previous sections is that what's going to happen is the graph will come touch and turn around and then come back down at 9 or something like that. I don't know if this is exactly what it looks like, but it will. At 0, it will actually come and touch and turn around. Now, it might come from the other direction, so that's what I'm saying. I'm not sure exactly what it looks like, but I know that it's going to have that type of behavior. Okay, so let's see. We'll go ahead and put 0 here, put 9 over here. Let's see, we'll test like negative 1, positive 1, and 10. Okay, so if we plug in negative 1, let's see, we're going to have negative 1 squared, and then if I plug in negative 1 right there, that'll become a negative 10. And I want to see if that's greater than or equal to 0. Well, negative 1 squared will become positive 1. And so then positive 1 times negative 10 is negative 10. Negative 10 is not greater than or equal to 0, so that will not be part of my solution set. The intercepts will be included because of the inequality symbol. Since we have the greater than or equal to, we do know that those points actually are included, so we'll go ahead and shade those in. Okay, let's try 1 now. So let's see, 1 squared times, let's see, 1 minus 9 would be negative 8, greater than or equal to 0. So we'll get 1 times negative 8 is greater than or equal to 0. Negative 8 is greater than or equal to 0. Let's see, that is going to be false. Negative 8 is not going to be greater than or equal to 0. Okay, now let's try 10. Let's see, 10 squared. 10 minus 9 is 1. Is that greater than or equal to 0? That looks like it will be, because we'll get 100 times 1. 100 is greater than or equal to 0, so that one will be true. So we'll want to shade out on that interval all the way to infinity. Okay, so the way we're going to have to put our interval set here is we have to include 0, so we're going to put 0, and then union, we want to include from 9 to infinity. Okay? All right, I hope that helps, and then we'll look at the rational ones in the next video.